All right, so this lesson is about inverse matrices. The reason that I want to do this lesson is because my Algebra 2 class just got finished with matrices. They did really decently on the test, but one of the things that most of the students, when I gave them a survey, said that they struggled with was inverses. We used inverses mostly just for solving matrices, which to me is not, I don't know, it's not my favorite method to solve, but it's a good method and it's good to know inverses, and you might be asked to find an inverse, you might be asked to prove inverses, so knowing how to find an inverse is, I think, important. So we're just going to do finding inverses. And then if it turns out that some of my students want to see how you then use this to solve, or they want to see proving matrices or proving inverses, excuse me, or they even want to go back to determinants, anything like that, I will show them because they have a final coming up. So for a matrix, you can just pick whatever numbers make you happiest. What number makes you happy? No, I want you to know what number makes you happy.
5.
5, okay. So we could do like 5, 2, -3, and I don't know, 4, something like that. The first thing you always do with a matrix is you always find its determinant when you're looking to find the inverse. Okay, so determinant is written like that, or it can be written with straight sticks with the matrix in the middle. And the way you find the determinant is you do main diagonal multiplied minus secondary diagonal multiplied. I had a college professor who said diagonal. So every single time we did this, she would say use the main diagonal and then subtract the secondary diagonal, which kind of drove me insane. Okay, 2 negatives make a positive. So our determinant is 26. Now, for the inverse, you're going to take this determinant and you're going to utilize it with the modified matrix. Okay, so what it looks like is, we'll pretend this is A. A is normally written like that. So to find the inverse, you take 1 over the determinant of A, which we found, and then you take the main diagonal and you switch them. And then the secondary diagonal, you keep it where it was, but you change its signs. Okay, so this is the form for an inverse matrix. So I have my determinant, it's going to go here. So I'm going to erase the word for my determinant. You'll be okay. Hopefully you were taking notes. Just kidding. All right, now what I'm going to do is I'm going to take my main diagonal and I'm going to flip the 2. So the 4 is going to move where the 5 was, and the 5 is going to move where the 4 was. The 2 is going to change sign, so it's going to become a negative, and the 3 is going to change sign, so it's going to become a positive. Here now you're just multiplying, and I think this is the part that my students struggled the most with because multiplication of fractions is not their favorite thing. So what I'm going to do is I'm going to distribute this 1/26 to each number in the matrix. All right, so when you multiply 1 over 26 times 4, that whole number is really 4 over 1. You multiply straight across, which gives you 4/26, which is really fun to say, 4/26. Okay, then you do the same thing here. You can also think of it, if you're a shortcut person, as just the top number times, so the numerator times the top number or the main number here. So that'll give me -2/26. Then times the 3 gives you 3/26. And then times the 5 gives you 5/26. Okay. Now, for the inverse, you can leave it like that, but I don't recommend it. I recommend you go ahead and you reduce everything that you can. So you just want to look and see, can I make 4 over 26 any smaller? 4 over 26 could reduce by 2. So half of 4 is 2, and half of 26 is 13. So that gives me 13, not 13, 2/13. Okay, same here, we're going to reduce that. It's going to stay negative, and it's going to become 2 divided by 2 is 1, and 26 divided by 2 is 13. 3 and 26 is not going to reduce nicely, so that one can stay. And then 5/26 is not going to reduce, so that one can stay. So the inverse, eraser, of these two matrices, well, of this matrix, is this matrix here. The way you prove that is you multiply them. Now, I taught my students how to use calculator for this because it's not a quick process, And if you're taking like the ACTs or the SATs where they let you use a calculator, that's going to be your fastest bet. You might be in a class where you're not allowed to use a calculator, or maybe you don't have a calculator that's fancy enough to do matrices multiplication. So the way you multiply matrices, you have to check their dimensions first. Okay, so it's always row by column. Row is the one that goes across, column is the one that supports a building. So this one is 2 rows by 2 columns. This one is 2 rows by 2 columns. These middle numbers have to match. They do, so I can multiply these. Now, when you multiply these, it's kind of weird. You turn them, sort of. Well, you don't turn them, but what you do is you take the first row times the first column. What's the matter, sweets? All right, sorry, that was Daniel got upset. They're watching Ghostbusters, and the Ghostbusters, the cartoon, and it scared him. All right, so what you do is you multiply the first number in the matrix times, so the first number in the row times the first number in the column. So you'll have 5 times 2/13. And then you'll multiply the second number in the row times the second number in the column. So 2 times 3/26. And then you'll add them. I'm going to run out of space. But what you want to have happen is you want this to turn into what's called the identity matrix. Which looks like that. So 5 times 2 is 10. I get 10/13 plus 6/26. I'm going to turn that into a 26, so I multiply it times 2. That's 20/26. And 20 plus 6 is 26/26s, which is 1. Okay? So I'm not going to do that whole process out. I can do a video on matrix multiplication if you want me to. But the idea with the matrix is when you multiply a matrix times its inverse, you should end up with the identity, but it has to work both ways to truly be an inverse. All right? So that's how you find the inverse of a matrix. I can do another one if you would like. I give you examples if that's what makes you happiest. But I need to know. And then I could show you how to then solve. So I don't know with my students whether the biggest issue was just finding the inverse because the fractions made you unhappy, or if it was actually taking that inverse then and multiplying to find an answer to a system. I don't know. All right, you have to let me know. So this is acidic. I did not do any sort of introduction because apparently I just don't do those. I'm low-key savage, is what I've heard. And yeah, if you like this, oh, look at this one. Watch this, Pulsatig. You can like and subscribe, and then you'll always get to see my videos, I guess, if that's what you're into. Or if you don't want to subscribe, that's totally fine. I'm not your mom. I don't care. But if you have things you want me to do, or things you want to see, or things you want me to clarify, go ahead and leave a comment in the comments section. Wow. Look at that. I'm a professional.